Hello, everyone. The first thing we're going to do is talk about special right triangles. There's two types of special right triangles. Please keep in mind, all of them are 90 degrees, meaning they're right triangles. So we have a 45-45 isosceles right triangle, and the second one we have is a 30-60-90 30-60-90 triangle, given that the angles inside the triangle. So the first thing I'm going to start with this video is just a 45-45-90 triangle. And the first thing I want to explain is we know it's isosceles. So if I gave you a triangle and gave you side lengths 3 and 3 and asked you to find Pythagorean theorem, 3 squared is 9 plus 9 is 18. The square root of 18 broken down is 3 root 2. If I asked you to do it with 4 and 4, it would be 16 and 16. And then when you break it down, you're going to get 4 root 2. If I asked you to do it with 5, it's going to be 5 squared and 5 squared, which comes out to be 50, and the square root of 50 is 5 root 2. So you should start to pick up something, that every time I use Pythagorean theorem, my hypotenuse is coming out to the leg root 2. The leg root 2, the leg root 2. These are the legs. So if I look down here, I already started your notes, and it says in a 45-45-90, the hypotenuse is the square root of 2 times as long as each leg. So every isosceles right triangle, you can use x root 2, or you can use hypotenuse equals leg times square root of 2. Now, I prefer the formula because I'll show you what I do here. So in example 1, you have 4 root 3. Well, I automatically know this side's 4 root 3 because it's isosceles, because 45 and 45 know they're the same. And so now if I know what the leg is and I'm trying to find the hypotenuse, I'll type in y equals 4 root 3 times root 2, and I will get 4 root 6. So this is 4 root 6. I don't need to do the Pythagorean theorem, okay? It saves me all this time by plugging it in. Can you use Pythagorean theorem? Sure, but you're going to have to do 4 root 3 squared plus 4 root 3 squared equals x squared. You're going to have to go through and simplify. Look how fast I did that. So in a 45-45-90, you can always revert back to Pythagorean theorem. Always, because you'll always know two sides are the same. So in this one, even example 2, I could do x squared plus x squared equals 2 root 2, squared. I don't want to do that all. I don't. So what I'm going to do is, if I know the hypotenuse, so if I go back to this, if I know the hypotenuse is 2 root 2, and then I know it's leg times root 2, and one of the legs x. This is multiplication. How do I undo multiplication? I divide by root 2. I divide by root 2. They cancel, and this one, x is 2. Can you use Pythagorean? Sure. Some people will, but I do think this saves you time. Let's look at this next one. X, Y, be careful. These are tick marks. These mean they're the same. So what I'm going to get is, I know that 9 is the hypotenuse. So I'm using this formula right here. 9 equals the leg, x or y, times root 2. Now, this is technically the harder problem because you're going to have to do a little bit of algebra, but let's look how easy. I divide by root 2 because that's what's going to get the root 2 to this side. So now I have 9 over root 2 equals x. And you know what? That is the answer. But in math, we cannot leave radicals in the denominator. So I'm going to multiply by root 2. I'm going to multiply by root 2. Everybody remember that? So across the top, I get 9 root 2, and on the bottom, I get 2. That's my answer. Some people might say, well, she's crazy. That's much harder than doing this. Let's look at this. X squared plus x squared equals 9 squared. People are going to forget that this becomes 2x squared equals 81. You now have to divide out the 2, so you get 81 over 2. And now you take the square root of that, and you get x equals square root of 81 over the square root of 2. And then I'll get 9 root 2, and I still have to do the same thing I did. So even if you think Pythagorean theorem looks easier, this is the math for Pythagorean theorem. All I had to do by using this was that. And then the next thing I gave you is this 7-4 practice to try these 6 problems, which are all 45, 45, 90. So the first thing I'm going to put on my page is hypotenuse equals leg times root 2. I'm going to just figure out, is it the hypotenuse that I'm given, or is it a leg? Whichever one I give you, plug in. So for example, I'm going to do number 5, because that's going to be one of your trickier ones, okay? 8 in the problem is the hypotenuse. So I'm going to put 8 equals x times root 2 because x is the leg. And this is the one where I divide by root 2. Okay, and I get x equals 8 over root 2. Not bad, except you must get rid of it off the bottom. So it becomes 8 root 2 over 2. Which is a great answer, except 8 and 2 can simplify to 4 root 2. Okay? And then, just be careful. So that was the hypotenuse. In number 2, this is a leg. 9 root 2 is the leg. The hypotenuse is x. The hypotenuse is always across from the 90 degrees. So x equals 9 root 2 times root 2. So x equals 9 root 4, careful, x equals 18 because 9 times 2, the square root of 4 is 2. So those are some examples from these 6. I'd like you to try the other 4 by yourself. And of course, I'll have stuff to follow up on this. And then you'll watch the 30, 60, 90. Thanks.